Alright, we're going to be reading from the private oral exam guide. I'm going to be in chapter 4, airplane systems. I'm going to be in section B, system and equipment malfunctions. This will be 4-10. What causes carburetor icing and what are the first indications of its presence? The vaporization of fuel combined with expansion of air as it passes through the carburetor causes a sudden cooling of the mixture. The temperature of air passing through the carburetor may drop as much as 6 degrees Fahrenheit within a fraction of a second. Water vapor is squeezed out by this cooling, and if the temperature in the carburetor reaches 32 degrees Fahrenheit or below, the moisture will be deposited as frost or ice inside the carburetor. For airplanes with a fixed pitch propeller, the first indication of carburetor icing is a loss of RPM. For airplanes with controllable pitch, constant speed propellers, the first indication is usually a drop in manifold pressure. What method is used to determine that carburetor ice has been eliminated? When heat is first applied, there will be a drop in RPM in airplanes equipped with a fixed pitch propeller. There will be a drop in manifold pressure in airplanes equipped with a controllable pitch propeller. If ice is present, there will be a rise in RPM or manifold pressure after initial drop, often accompanied by intermittent engine roughness. And then, when the carburetor heat is turned off, the RPM or manifold pressure will rise to a setting greater than before the application of heat. The engine should run more smoothly after the ice has been removed. What conditions are favorable for carburetor icing? Carburetor ice is most likely to occur when temperatures are below 70 degrees Fahrenheit or 21 degrees Celsius, and the relative humidity is above 80%. However, due to the sudden cooling that takes place in the carburetor, icing can occur even with temperatures as high as 100 degrees Fahrenheit, 38 degrees Celsius, and humidity as low as 50%. This temperature drop can be as much as 60 degrees to 70 degrees Fahrenheit. Define the terms anti-icing equipment and de-icing equipment, and state several examples of each. Anti-icing equipment prevents ice from forming on certain protected surfaces. Examples are heated pitot tubes and static ports, carburetor heated fuel vents, propeller blades with electrothermal boots, and heated windshields. It is normally actuated prior to flight into suspected icing conditions. Reference your AFM-POH. De-icing equipment removes ice that has already formed on protected surfaces. It is generally limited to pneumatic boots on the wings and tail leading edges. Describe how an aircraft de-icing system works. Upon pilot actuation, boots attached to the wing leading edges inflate with air from a pneumatic pump to break off accumulated ice. After a few seconds of inflation, they are deflated back to their normal position with vacuum assistance. The pilot monitors the buildup of ice and cycles the boots as directed in the AFM-POH. If an airplane has anti-icing and or de-icing equipment installed, can it be flown into icing conditions? Even though it may appear elaborate and complete, the presence of anti-icing and de-icing equipment does not necessarily mean that an airplane is approved for flight into icing conditions. The AFM-POH placards and even the manufacturer should be consulted for specific determinations of approval and limitations. What is detonation? Detonation is an uncontrolled explosive ignition of the fuel-air mixture within the cylinder's combustion chamber. It causes excessive temperature and pressure which, if not corrected, can quickly lead to failure of the piston, cylinder, and or valves. In less severe cases, detonation causes engine overheating, roughness, or loss of power. Detonation is characterized by high cylinder head temperatures and is mostly likely to occur when operating in a high power setting. So detonation is an uncontrolled explosive ignition of the fuel-air mixture within the cylinder combustion chamber. Uncontrolled. What are some of the most common operational causes of detonation? Using a lower fuel grade than that specified by the aircraft manufacturer. Operating with extremely high manifold pressure in conjunction with low RPM. Operating the engine at high power setting with an excessive lean mixture. Extended ground operations or steep climbs where cylinder cooling is reduced. What action should be taken if detonation is suspected? Corrective action for detonation may be accomplished by adjusting any of the engine controls, which will reduce both temperature and pressure of the fuel-air charge. Reduce power, reduce the climb rate for better cooling, enrich the fuel-air mixture, Open cowl flaps if available. Also ensure that the airplane has been serviced with the proper grade of fuel. What is pre-ignition? Pre-ignition occurs when the fuel-air mixture ignites prior to the engine's normal ignition event, resulting in reduced engine power and high operating temperatures. Premature burning is usually caused by a residual hot spot in the combustion chamber, often created by a small carbon deposit on a spark plug, a cracked spark plug insulator, or other damage in the cylinder that causes a part to heat sufficiently to ignite the fuel-air charge. As with detonation, pre-ignition may also cause severe engine damage because the expanding gases exert excessive pressure on the piston while still on its compression stroke. What action should be taken if pre-ignition is suspected? Corrective actions for pre-ignition include any type of engine operations which would promote cooling, such as reduce the power, reduce the climb rate for better cooling, enrich the fuel-air mixture, open cowl flaps if available. Alright, number 12 on 4-14. During the before takeoff run-up, you switch the negatives from both position to the right position. Notice there is no RPM drop. What condition does this indicate? The left P lead is not grounding. Or the engine has been running only on the right magneto because the left magneto has totally failed. Interpret the following ammeter indications. Ammeter indications indicates a right deflection, positive. After starting, power from the battery used for starting is being replenished from the alternator, or if a full-scale charge is indicated for more than 1 minute, the starter is still engaged and a shutdown is indicated. During flight, a faulty voltage regulator is causing the alternator to overcharge the battery. Reset the system, and if the condition continues, terminate the flight as soon as possible. The ammeter indicates a left deflection, negative. After starting, it is normal during start. At other times, this indicates the alternator is not functioning or an overload condition exists in the system. The battery is not receiving a charge. During flight, the alternator is not functioning or an overload exists in the system. The battery is not receiving a charge. Possible causes: the master switch was accidentally shut off, or the alternator circuit breaker tripped. What action should be taken if the ammeter indicates a continuous discharge while in flight? The alternator has quit producing a charge, so the alternator circuit breaker should be checked and reset if necessary. If this does not correct the problem, the following should be accomplished. The alternator should be turned off, pull the circuit breaker, the field circuit will continue to draw power from the battery. All electrical equipment not essential to flight should be turned off. The battery is now the only source of electrical power. The flight should be terminated and landing made as soon as possible. What action should be taken if the ammeter indicates a continuous charge while in flight, more than 2 needle widths? If a continuous excessive rate of charge were allowed for any extended period of time, the battery would overheat and evaporate the electrolyte at an excessive rate. A possible explosion of the battery could result. Also, electronic components in an electrical system would be adversely affected by higher than normal voltage. Protection is provided by an over voltage sensor, which will shut down the alternator if an excessive voltage is detected. If this should occur, the following should be done. The alternator should be turned off, pull the circuit breaker, the field circuit will continue to draw power from the battery. All electrical equipment not essential to flight should be turned off. The battery is now the only source of electrical power. The flight should be terminated and landing made as soon as possible. During a cross-country flight, you notice that oil pressure is low, but the oil temperature is normal. What is the problem and what action should be taken? A low oil pressure in flight could be the result of any one of several problems, the most common being insufficient oil. Yes. If the oil temperature continues to remain normal, a clogged oil pressure relief valve or an oil pressure gauge malfunction could be a culprit. In any case, a landing at the nearest airport is advisable to check for the cause of trouble. Alright. What procedures should be followed concerning a partial loss of power in flight? If a partial loss of power occurs, the first priority is to establish and maintain suitable airspeed, best glide airspeed if necessary. Then select the emergency landing area and remain within gliding distance. As time allows, attempt to determine the cause and correct it. Complete the following checklist. Check the carburetor heat, Check the amount of fuel in each tank and switch fuel tanks if necessary. Check the fuel selector valve's current position. Check the mixture control. Check that the primer control is all the way in and locked. Check the operation and the magnetos in all three positions, both left and right. What procedures should be followed if an engine fire develops in flight? In the event of an engine fire in flight, the following procedures should be used. Set the mixture control to idle cutoff. Set the fuel selector valve to off. Turn the master switch off. Set the cabin heat and air vents to off. Leave the overhead vents on. Establish an airspeed of 100 knots, indicate airspeed, and increase the descent. If necessary, define an airspeed that will provide for an incombustible mixture. Execute a forced landing procedures checklist. 19. What procedures should be followed if an engine fire develops on the ground during starting? Continue to attempt an engine start, as the start will cause flames and excess fuel to be sucked back through the carburetor. If the engine starts, increase the power to a higher RPM for a few moments, then shut down the engine and inspect it. If the engine does not start, set the throttle to the full position, set the mixture control to idle cutoff. Continue to try an engine start in an attempt to put out the fire by vacuum. If the fire continues, turn the ignition switch off, turn the master switch off, set the fuel selectors to off. In all cases, evacuate the aircraft and obtain a fire extinguisher and or assistance. Continue to attempt an engine start, as a start will cause flames and excess fuel to be sucked back through the carburetor. Alright, we're going to hold off there. That was number 19. We're on 4-17. That's Chapter 4, Airplane Systems. We'll be going into C, Pedostatic Flight Instruments, right after this. See you.